case study of a customer who we dealt with recently, and their material was actually pretty narrowly distributed, they believed, and let's say it had an average size of 30 microns. But upon analysis, using our submicron end of the LS instrument, we discovered, which they suspected, that they might have some very small material. And it turned out they had a pretty significant portion of their distribution was something around 300 nanometers or 0.3 microns. So they were calling it a 35 micron preparation, but it had very small particles in there, which to the extent of maybe if it's 3 or 5%, you'd say, well, it's not significant. But that depends what you're going to do with it. If, for example, you were moving this through a process and it had to pass through a valve someplace where there was a ball valve, and everything was fine if it was 20 to 40 microns, but those little small submicron particles could be small enough to fit in to the space between the place where this ball valve rotates and cause a failure of the process because they didn't know it was there. So knowing it's there is a lot to do with why you want to disperse your sample and characterize it accurately. Because if you didn't disperse it and you never saw the 300 nanometer particles, you could be having failures and have no idea to look in that particular area for the failure. So the distribution aspect of it is very critical. So just because something is supposed to be a tight uniform distribution doesn't mean that's what it's actually got, except if you're looking at 90% of it, you say you're happy. But you got to remember, if over time those little things are building up somewhere and causing a failure, you really want to know they're there. So you don't have to worry about them until there's a failure, but it's better to know they're there than to not know they're there. So that's why you disperse things.